everybody's favorite, motion. Okay, here's my function. It's the displacement. And of course, we know time always has to be greater than or equal to 0. Find the velocity and acceleration function. So, I've started with a bit of a whoopsie here. It's not the velocity, that's still my displacement function, because what I've done is I've expanded this first to make life easier for myself. So now, when I go to differentiate, it's going to be a little bit easier. So derivative for constant is nothing. We write the function e to the minus t over 10, remembering that minus t over 10, we'll just do it over here, minus t over 10, that is the same as saying minus 1/10 times t. So what is the derivative? We have to now multiply by the derivative of that, and the derivative of that will be just minus 1 over 10. And that makes minus 100 times minus 1 over 10. Negatives cancel and we get 10 e to the minus t over 10. And now the acceleration, I don't know why I put a little dash there. The acceleration is now the derivative of this. So we write the function times the derivative of minus t on 10, which we did from above, which is minus 1/10. So now this becomes minus, because 10 times minus 1 over 10 is minus 1e to the minus 10 t over 10. Okay? So here's my acceleration function and velocity function. So we've got that. Find the initial position, velocity, and acceleration of the body. Okay, well, I think it's time for a color change. We'll go to orange. So S of 0, I know I should have gone X, but anyway, S of 0, that's 100 times 2 minus e to the 0, and anything to the 0 is 1. 2 take 1 is 1, so I've got 100 centimeters. It's positive, so that means it's 100 centimeters to the right. V of 0, I think you can now work these out. So just jumped ahead a little bit. I think you can do this yourself. So all I could say here, I guess, is watch your units. So make sure it's centimeters. For velocity, it's centimeters per second. Acceleration is per second. Find the position, velocity, and acceleration when t is 5. So you'll just go back and substitute 5 in there. I think you can do that. Find t when x of t equals 150. So we'll do that one. A little bit of algebra, nothing I don't think you could I think you can't handle. So D, we've now got 150 equals 100. 2 take e to the minus t over 10. Oh, you can do a whole lot here. If you want to, you can divide by the 100, or you can do what we did before and expand. Don't think it really matters. I'm not in the mood for fractions at the moment, so I'm going to go 100 equals 200 take 100e to the minus t over 10. So we get rid of that. 150 take becomes minus 50 equals minus 100e to the minus t over 10. Try to avoid the fractions, but here they come. Negatives cancel. 50 over 100. It's a friendly fraction and a half. E to the minus t over 10. Now we're allowed to get rid of the e's for ln. So remember our little trick with the half. That's ln of a half, but a half is 2 to the minus 1. So I'm straight away going that's minus ln 2 minus t on 10. Negatives will cancel, and therefore t is 10 ln 2. Explain why the speed of the body is decreasing for all t and velocity is always decreasing. So 2 questions in one there. So we go back, why do we know, or when is the speed decreasing? So hopefully you've got that orange sheet that you have with all the tables, and we know that the speed is decreasing when the velocity and acceleration are different signs. So how can we tell that they are different signs just by looking at this? Well, again, it comes back to knowing your graph of e to the minus x. So remember, we looked at that in the previous question. This is e to the minus x, not a great drawing there, but we can see that it is always above the x-axis. In other words, it is always positive, and we're timesing it by 10, so that means that for all values of t, the velocity will always be positive. The same can't be said for the acceleration, because this bit here, e to the minus t over 10 again, that will always be positive, but then you're timesing it by -1, so that means the acceleration will always be negative, and therefore that's when the speed will be decreasing. So you can just say that in words if you want to. So we could say as e to the minus t on 10 is greater than 0, so it's positive for all t, then v of t is greater than 0 and a of t will be less than 0. Therefore, different signs, speed is decreasing. What about for the velocity? When is the velocity decreasing? Again, know what each of your things represent. And we know that when the acceleration is negative, that's when your velocity is decreasing. So that comes back to here again. We know that, again, how can we write that as a of t from above is less than 0. That gives velocity is always decreasing. I guess we should say for all t, or for t greater than or equal to 0, that's probably better. Velocity is always decreasing. Okay, hope that helps a little bit. Didn't really talk too much about displacement. That doesn't come up a lot with E's and LNs, but if it does, have a go and come back and see me. Good luck.